Yeah? Yeah. Alex, it's time to go to school. Wake up! Wake up!
Wait, where's your emergency?
Calculate something.
Where's your emergency?
Where's your calculator? Hold your calculator up. He's got it. He's got it out. Where is it? That is not a calculator. That's a phone. Do you have a calculator, sir? No. Here. No. We get it out. For the love of Newton.
Where's your emergency right away?
All right, are we ready for the next one? A ray of light has an incident angle of 12 degrees. What is the refracted angle in the air? So in this case, I make the 1.33 N1 because that's the first place it is. That's my convention. It really doesn't matter which one you do because it's like one of these beautiful things, right? So I'm going to go 1.33 times sine 12 equals 1.00. And I'm making theta 2 be the one in the air, but if you secretly do it the other way, look at you. Yeah. Yeah. I'm communicating with someone on the other side of the wall. That's right. That's right. That's right. Huh? No sé.
We should find out. What's your name in Morse code? Oh, God.
Yes. They weren't expecting that. That wall ain't all that well put together. They probably got yelled at by the teacher. Yeah, that's right. Let's go hunting. Probably some freshmen in there. That's right. That's right. My water tastes salty. There's a little bit of firecracker in my water. When I was a kid, I used to eat matches. That's right. After they were burned. Salty. Have you ever tried them? That's right. I was a regular Yule Gibbons. Are we all good? Have we all solved that for that guy? Yeah? You've got to do a inverse. You got to do an inverse sine, right? Theta 2 is going to be sine minus 1 of this 1.33 sine 12 divided by 1.00. I know you don't have to divide by it, but there it is, right? Are they over there? They probably got a bathroom pass, and that's pretty funny. All right. Okay, it's 32 degrees the incident angle. No, so the angle we would use in our formula is
90 minus. What's 90 minus what? 33.
90 minus 32, because that's the, look how it's drawn. This formula works with this angle, not that angle, correct? So 5/8 would be the correct angle, correct? Yeah. Okay. So now let's, this formula now looks like this. N1, and I always call the first thing you're in N1. N1 is 1.33, that's the water. Sine 58 equals N2, and N2 is just in this case 1.00, right? And then sine theta 2. See if you can solve for theta 2. It's important that you do this. Even if your name is Brody. Are you just getting your calculator out? You're a very bad boy. I'm going to release a war balloon on you. Release the balloon of war. If you do not calculate this, I will release my balloon on you. Do I need to release my balloon?
I'm calculating.
Not fast enough. Okay. Is there something Harry Potter about the way it does its last little It's like that letter that what do they call them? The letter from home. It's called a howler.
The ones that have
Yeah, the letter goes and then has a little snit. You guys are taking a little long time here to get this answer here. It's just simple algebra. If your calculator doesn't work, try pressing the numbers harder. Do the same calculation again. It's a sign of insanity. What could that possibly mean in this case? That it cannot be calculated? Yes, but what does it physically mean?
The light is fake.
There's no solution is correct.
The light is real.
It's not real.
There is no light?
There is no light. It doesn't escape the surface.
Oh, it bounces back.
Let me release the balloon of war one more time, and then I'll explain.
It bounces back in the water.
Ah! Where did it go between them? You're a very bad balloon. I am brave like my dog. Did not expect that. All right. I think let's subject this problem to some critical thinking. Let's subject this problem to some critical thinking. Okay? Think about this. As I send a ray of light straight out, of course, all that happens is the wavelength gets longer and it goes straight up. Right? If I send it at some angle, it bends like that because it's the left side speeds up first and there it goes, right? If I send it at this angle, it bends, right? If I send it at this angle, it just barely gets above the surface of the water. Yeah? Okay, so the fish down here, when they look up at the surface of the water, when they look there, they're actually seeing these things retrace themselves, right? They're actually seeing, when they look there, they're seeing the edge of the lake. I mean, literally what's right on the edge of the lake. If you're standing right at the edge, they'll see you. Okay, they'll see you anywhere. They're going to see, if it's visible from the lake, they will see you. Okay, it's all distorted, but yeah, salmon, smart fish are they're smart. Okay, now, what happens if I shoot it at this angle here? Isn't there some angle where the refracted angle is like 90 degrees? What does that mean? Isn't this angle here going to hit 90 degrees way before this angle hits 90 degrees? Yeah? What does that mean if it's 90 degrees? Have you ever looked up from the bottom of a pool? I do this.